Hello everyone. Okay, so in this video we're going over the trapezoidal rule. So what is the trapezoidal rule? Basically, the trapezoidal rule is a formula that gives us an approximation of like the area under a curve or the area under a graph. So if you see like this kind of shapey here, so kind of have a curvy bit here, I'm trying to find the area of that shape or an approximation for the area of that shape. So this is used in like ordnance geography, where like we might calculate the surface area of like a lake or a mountain range or a park or a green, etc. So this is a good way of calculating an approximation of these kind of irregular shaped shapes. Right, so the formula is very straightforward. It's just the area is approximately equal to h over 2 times the first height of it plus the last height plus 2 times the sum of the remaining heights, where h is not a height, right? They're being little sneaky little snakes. It's not a height. It is the horizontal width of the columns I'm making, right? So the columns have to be a consistent width. In this case, we call that h. So let's try it out. So this is from the 2017 paper. So a field is divided into 8 sections as shown below. The width of each section is 3 meters. And the height in meters of each section is given in the diagram. Use the trapezoidal rule to estimate the area of this field. So I need to find my h. So h is going to be equal to 3 meters. My first height is going to be equal to 4. That's my first height. My last height is going to be equal to 8. And then the sum of remaining heights, sum SOR, sum of remaining, just so we don't have to write it out. The sum of the remaining heights is going to be 5.8 plus 7 plus 6.5 plus 6 plus 4.8 plus 6 plus 6.5. So I'm going to add these up now. Hopefully I add up right. 5.8 plus 7 plus 6.5 plus 6 plus 4.8 plus 6 plus 6.5. The sum of the remaining is equal to 42.6 meters. So, meters there. So let's look at my formula. So the area is approximately equal to h over 2 times first height plus last height plus 2 times sum of remaining. So it's going to be 3 over 2, 4 plus 8 plus 2 times 42.6, 3 over 2 times, inside of my bracket is going to be equal to 97.2 over 3 divided by 2, and then multiply it by 3 over 2. I'm going to get the area is approximately equal to 145.8 meters squared. And that is my answer there. So the area of this field is approximately equal to 145.8 meters squared. So let's have a look at another one here. So the area of the same field was re-estimated by applying the trapezoidal rule again. This time, a different section width, 4 meters, and a different set of section heights were used. As shown, the area was found to be 145.6 meters. Right, so we've now selected a new width, and now we've gotten a new approximation for the area of the field. So use this information to find the value of the height marked x. So I have an unknown here, I have an x here, I have an unknown. So I'm trying to solve for that. So let's sub in all of my values of my formula here. So my area is going to be equal to 145.6. My first height is equal to 4. My last height is going to be equal to 8. And then the sum of the remaining heights is going to be 6.4 plus 6.9 plus 6 plus x plus 6.2. So remember, group my like terms, so add all my numbers together. 6.4 plus 6.9 plus 6 plus 6.2. I'm going to get, and then plus x, I'm going to get 25.5 plus x. That is the sum of my remaining heights. So let's sub it into my formula. So the area is equal to h over 2. Oh, and my h is going to be equal to 4 meters. So the width between each column is 4 meters. So h over 2 times my first height plus my last height plus 2 times sum of the remaining heights. So my area is equal to 145.6. That's going to be equal to 4 over 2 times 4 plus 8 plus 2 times 25.5 plus x. Sorry, it's a bit messy there. 0.5 plus x. 145.6 going to be equal to 4 over 2 is 2. So 2 times 12 plus 51 plus 2x. Right, because I'm multiplying the 2 in, so 2 times 25.5 is 51, and 2 times x is 2x. 145.6 is approximately equal to, this is going to be 2 times 63 plus 2x. 145.6 is equal to 126 plus 4x. Bring my 126 over, change the sign. I'm going to get 19.6 is equal to 4x. Then I'm going to divide both sides by 4. Bada boom. I'm going to get x is equal to 4.9 meters. So therefore, I have solved for my missing height here. So that is another application of trapezoidal where I can find the length of missing heights. Or another question you could be asked with them. Okay, so when working with the trapezoidal rule, it's also important to look out for shapes like this. So kind of like a lemony shape, right? So where I have lengths on the top and the bottom, right? So, and then if you look here in this shape as well, my top height and my bottom height seem to kind of curve off and close. So when you see them kind of close at the end like this, right? Your first height is going to be 0 and your last height is going to be 0. So if they kind of curve off at the end and no height is given, the height itself is going to be 0. And then the sum of the remaining heights is literally going to be this height added together, which is 12 plus 14, which is 26. 26 plus 32 plus 49 plus 17 plus 22 is 39. And then plus the remaining here, which is 32, I think. Right? So you add them heights up together. And they will be your remaining heights. Right, so let's use the trapezoidal rule and now do it proper. So, have a look here. My height, or my, not my height, sorry, my h, my horizontal distance between each column is going to be 20. Right? It's going to be given as 20. My first height is going to be 0 because it kind of clasps off at the end there. My last height is going to be 0 as well because, again, it clasps off here. And then the sum of my remaining heights, right? The sum of the remaining heights, well, that's going to be 12 plus 14 plus 20 plus 12 plus 23 plus 26 plus 17 plus 22 plus 14 plus 18. You're going to add all of them up together, and you are going to get, let me just reveal the workings here. You're going to get 178. That's the sum of my remaining. And now we just sub it in. And now we just sub it in here. So my area is approximately equal to h over 2 times first height plus last height plus 2 times the sum of the remaining. It's going to be 20 over 2 times 0 plus 0 plus 2 times 178. So 10 times 356. The area is going to be approximately equal to 3,560 meters squared. So that is the approximate area for this kind of lemon. lemon shape. Right, so let's look at another example here from an exam paper. So we now have here, the diagram below shows the plan of a lake. So the line segment PQ represents the distance from the pier to the lake. Okay, whoop-de-doo. At equal intervals of 10 meters along this line, a perpendicular measure of both sides are shown. Use trapezoidal rule to find the surface area of this lake. So again, same thing. My horizontal distance H is going to be 10, right? So they told us in the question, right, it's at equal intervals of 10 meters. So what's my first height? Well, if you see here, it's not really kind of clasped off. So my first height here is actually going to be 10. Then my last height is going to be 0 because it has kind of clasped off at the end here. So my last height is going to be 0. And then sum of the remaining heights, well, that's going to be, so 20 plus 20. Right, so add them together. 10 plus 30. So 10 plus 20, sorry, I should say. Got ahead of myself there. 30 plus 20. Plus 30 plus 10. And then plus 20 plus 20. So I'm literally adding these two heights together. So let's have a wee little gander. So 40 plus 30 plus 50 plus 40 plus 40. My sum of the remaining heights is 200. So the area is approximately going to be, so remember h over 2 times first height plus last height plus 2 times sum of remaining. So 10 over 2 times 10 plus 0 plus 2 times 200. So 410 times 10 divided by 2. So I'm going to get approximately, put all this in my calculator, I'm going to get the approximate area of this lake to be 2,050 meters squared. And that's going to be the approximate area of this lake, or the surface area of this lake. If the lake is on average 8 meters deep, estimate the volume of water in the lake. So in this case now we're finding the volume of the lake. So I have a very irregular shape here, and I have a depth. So this might look like it, but this is actually going to be a prism. Yeah. So the second part here is going to be the volume of a prism. So the volume of the prism is equal to area of cross section times height. As we know, the area of my cross section is going to be 2050, and then my height, or my depth, is 8 meters. So multiply that by 8, and we're going to get 16,400 meters cubed, and that is the volume of water in the lake. Right, now finally, one more question I just want to look at here. So sometimes you could be given a graph, and you could want to be asked to calculate the area underneath a graph. So in this case, right, I need to find my vertical height at these points. So if you see here, I have a graph here. I don't know what the graph is. Deal with it, right? I've made columns now, each of length 1 unit. Yeah. Bing, bong, 1 unit. Bing, bong, 1 unit, right? So I know for this case, h is going to be equal to 1. Gorge. So what's my first height? Well, I'm going to need to read it off the graph. So I'm going to look at my first height here. This is going to be 3, kind of. Right? So I'm going to say it's 3. What's my last height? Well, my last height is going to be 20? No. Let's take out a ruler here and let's do it properly. Right. Let's see. So, what's that? Will we say 19? I think we'll say 19. So my last height is 19 meters. So let's get the remaining heights here. So, at my first column, I'm going to say 4. Second column, I'm going to say don't know. 8, 9, 7? So, will we say 7? Yeah. Yeah, go on. Let's say 7. That's going to be 7. This height here is going to be... Mm, what do we say? 12. Yeah, go on. Let's say 12. That's going to be 12. And then finally, we know my last height is 19. Gorge. So now I have all my heights here. So the sum of the remaining heights. So my remaining heights are 4, 7, and 12. Add them up. And I'm going to get 11 plus 12 is a number 23. Gorge, that's some of my formula. So the area under this graph is going to be approximate by h over 2 times first plus last plus 2 times sum of remaining. Gorge. 1 over 2 plus my first height, which is 3, my last height, which is 19, plus 2 times sum of the remaining, which is 23. Shove all of that into your calculator. So I'm going to get a half of 68. So the area under this graph is approximately going to be 34 units squared. And I'm saying units squared because it doesn't give me any other measurements. So that is how we can read it off a coordinate graph. And that is all I have for today on the trapezoidal rule. I hope it was some help. Probably wasn't. But you know what? Right. I'll catch you guys later. Bye. Yeah.